0 to 0 change, right? Okay. So same thing for L2, L3, and L4, right? So once we get this 4 hash code right here, we can further combine these 2 hash code together, forming a new document. Okay, and these 2 hash code 0-0 and 0-1 will be fed into the hash function again and generate a new code, right? Okay, so any modification of this document can reflect that. You can see the top hash is not matched, right? So if we continuously combine, so for instance, hash 0 and hash 1, when we combine, we fed into the hash and generate a root node. And root node actually is another new hash code. And this hash code is the combine of hash 0 and hash 1, right? So in this manner, we can easily detect, for instance, if somebody change L2, okay? So you don't need to investigate on the right-hand side because it's not relevant to that, right? So you can easily trace and find, okay, L2 change. All right, so that can save a lot of time when searching which part of the document has been modified. We can easily detect. Okay, if you are, for example, if you put all the transactions in a single chain, it's too long. So you need to spend a lot of time to investigate, right? But if you are organized them as like, for example, binary tree, local tree, you can easily detect any modification of the document. All right? Okay? So when you put this all together, actually it forms a very secure way that anybody modify the content can be detected. All right? So that's why the blockchain has the 2 properties as I listed before here. Okay, the provenance and immutability, right? So immutability indicates that the blockchain you are not able to modify because any modification will trigger the hash code not matching. All right, so you can detect it. And provenance because the hash actually is dependent from the previous one, so the entire chain are linking together. Any modification in the middle will break the chain, right? So you can trace from the end of the chain back to its origin. If you're looking for a particular transaction, you can follow the chain and identify its source. All right? So basically, that's the concept of blockchain. Okay? Any questions? It's a short talk. Okay?
So basically, we're using the hash code for security key.
Correct.
Okay.
Right. Okay.
Every time there's any change in any block, it propagates to the root?
You mean the Markov tree, right?
Right.
Yeah. Yeah. When we submit a transaction, actually it's not, when you submit a single transaction, you add to the block directly.
Okay.
It creates a Markov tree first, right? So when you create a Markov tree, actually in the block, you actually not store the entire tree, you store the hash code. Right. The hash code of the Markov tree. It's the root node.
So what's its the main application, or who will be the customer or user
Okay.
of this?
Okay. So basically, blockchain, how do we apply? What is the application of blockchain? Basically, we need to consider about the property of that. Okay. First, you can use blockchain to tracking something. So if you have need to track, blockchain is, you may need to consider about blockchain. And the second thing is the thing you are going to track cannot be alteration. Okay, any alteration should be a record right there. You should not be able to have the capability to change any of the document even for a bit. All right, okay. So, for example, in accounting, you don't want anything. For example, you want to track how the money are spent. Okay, for example, the money are from the money you, for example, you buy the copy machine, right? Okay, so copy machine is an asset. Money is another type of asset, right? So you want to change, you want to track the cash flow. So how it change? So you have all the record right there, and you don't want anybody to modify any part of it. For example, if I stole some of the money in the middle, right? So you don't want that happen.
So to visualize it, so if somebody does attempt to change something, and if we're kind of picturing this based off of the tree,
Right.
is that change effectively just the branch that splits off from the original one is not even touched at all, or?
Yeah, the mechanism after this design actually is a distributed concept. Okay, the distributed concept is kind of like a majority vote. Okay, so since the same ledger are distributed among different nodes, so if any single point or multi-point modification, so that will trigger inconsistent, right? So at that moment, the majority will give a vote and try to change to restore the change back to the majority.
And I think we may have discussed this in our last session, but
Mhm.
there's no real limitation to how far the chain can go. So if I have a trillion blocks,
Yeah.
it should all still be fine.
Right.
Okay.
And
But
also,
that is actually a downside of using blockchain, because if you keep adding to blockchain, right, it can grow quite fast, because you are not just adding a new node. You are taking all the existing data and then add a new thing to it, and then you use hash function to generate a hash of that entire thing, not just the new additional piece. So if you keep adding new stuff, the space can actually grow quite fast. So that's why you shouldn't try to store everything in blockchain. If possible, probably a better way to use blockchain is to mix it with a traditional relational database. So if you're storing movie files, you don't want to store movie files in blockchain. You will store that in a typical database, but you will only store a metadata of the
Right.
movie in blockchain.
Okay, makes sense.
yeah,
The way I've seen it implemented, people would actually take, say, intervals of maybe 10 to 30 minutes and just copy all the transactions that occur in that 10 to 30 minutes and make that one data block.
Yeah, that's what Dr. Chen was saying. So instead of adding a new block every time that you have a new transaction, you actually wait and gather enough number of transactions and then create a block of it, then store it. Another thing is if the first the slide that Dr. Chen shared with us was it showed a genesis block,
right.
right? So if the data gets too big to handle, then you can always decide to start fresh at a certain moment. So store everything up to that moment in a safe place,